During the short period of 3 years, between 1969 and 1972, humanity managed to send humans to the moon 6 times. In total, 12 astronauts walked on the lunar surface, and the feeling at the time was that this milestone in space exploration would become a regular occurrence. However, more than 5 decades have passed, and no one has returned to the moon. The question that still lingers is, why, after the success of the Apollo missions, have we never gone back? To understand this question, it's essential to consider the historical context. During the Cold War, the United States and the Soviet Union competed for global supremacy in various areas, and the space race became an important battlefield. Although the Soviets achieved several pioneering feats, such as launching the first satellite and sending the first human into space, the Americans won the ultimate prize landing on the moon. This achievement, symbolized by the US flag planted on the lunar surface, represented victory in the space race. However, with this victory, public interest in lunar exploration began to wane. The immense cost of sending humans to the moon, combined with the perception that the US had already proven its dominance in space, led the American government to suspend the Apollo program. The end of the manned missions left many feeling that the dream had ended prematurely, and NASA shifted its focus to other areas. Although the Apollo program ended, its legacy is still present in our lives. Many technological and scientific advances emerged as a result of these missions, directly impacting people's daily lives. For example, cordless tools, now found in drills and vacuum cleaners, were initially developed so astronauts could work on the lunar surface without being tethered to a power source. Another significant advancement came in the area of safety. After the tragic Apollo 1 fire, which killed 3 astronauts, scientists developed fire-resistant fabric, still used today in firefighter gear. Additionally, NASA's research on water purification during long space missions led to improvements in hemodialysis machines, essential for kidney patients. The need to preserve food for astronauts also spurred the development of dehydration and freezing techniques, technologies that are now commonplace in frozen meals. These examples show how lunar exploration brought benefits beyond the space sector. Despite the progress, returning to the moon has always faced a significant obstacle cost. In the 1960s, NASA received about 5% of the United States' total budget, but that amount has progressively decreased over the decades. Currently, the agency receives less than 0.5% of the federal budget, making large-scale missions like those of the Apollo era unfeasible. Several US presidents have proposed returning to the moon, but political disagreements and high costs repeatedly shelved these projects. Meanwhile, NASA focused its efforts on other missions, such as building the International Space Station and launching the Hubble and James Webb Space Telescopes, both aimed at exploring the origins of the universe. While sending probes into space is a cheaper and safer alternative compared to manned missions, it has overlooked the human aspect of exploration, something that has always fascinated people. Many still dream of astronauts returning to the moon, and NASA's Artemis Project promises to fulfill this dream soon. In recent years, a new space race has emerged. This time, the main competition is not between the United States and Russia, but between the United States and China. China has already announced plans to send astronauts to the moon by 2030, and the US, determined to maintain its leadership, launched the Artemis Project, which aims to return humans to the moon by 2026. One of the primary reasons for this renewed interest in the moon is helium-3, a rare isotope with the potential to revolutionize energy production. Helium-3 can be used in nuclear fusion, a process that generates large amounts of energy without producing radioactive waste, unlike nuclear fission, which is currently used in power plants. Fusion with helium-3 would be an extremely efficient and clean way to generate energy. However, this isotope is very rare on Earth. On the other hand, the moon contains larger amounts of helium-3 deposited over billions of years by solar winds. However, the concentration of this isotope in the lunar soil is low, requiring a complex and expensive infrastructure for its extraction. Despite these challenges, mining helium-3 on the moon could be one of the main reasons for establishing a permanent lunar base, which would not only serve to extract this resource but also as a support point for future missions to Mars. The Artemis Project is divided into several phases, each more ambitious than the last. The first mission, Artemis 1, was launched in 2022 and successfully tested the launch systems and the Orion capsule, which will transport astronauts to the moon. This mission was unmanned, but was essential to ensure the safety of all components for the upcoming phases. The second mission, Artemis 2, is scheduled for 2025 and will be the first manned mission. 4 astronauts, including the first woman and the first black man to travel into deep space, will orbit the moon, preparing the way for the landing that will take place in the Artemis 3 mission, scheduled for 2026. This long-awaited mission will bring humans back to the lunar surface after more than 50 years. The Artemis Project also has long-term plans, such as building the Lunar Gateway, a space station that will orbit the moon and serve as a support point for future missions. Additionally, NASA plans to establish a lunar base at the moon's south pole, where large deposits of frozen water are believed to exist. This resource will be essential to sustain human presence and produce rocket fuel, allowing for the exploration of more distant regions of the solar system. One of the major objectives of the Artemis Project is to use the moon as a launch platform for future missions to Mars. Establishing a permanent presence on the moon will allow NASA to test new technologies and procedures in a low-gravity environment similar to what astronauts will encounter on Mars. Furthermore, the moon's reduced gravity makes launches more fuel-efficient, facilitating longer journeys. Although the Artemis Project represents a significant milestone in space exploration, many challenges remain. In addition to the exorbitant costs, issues such as protecting astronauts from cosmic radiation, developing long-term life support systems, and regulating the use of lunar resources are significant obstacles that must be addressed. Space tourism, which has already started to develop with companies like SpaceX and Blue Origin, may also play a role in the future of lunar exploration. However, commercial trips to the moon are still far from becoming a reality for most people, currently accessible only to a small elite. Moreover, a legal framework is necessary to regulate these activities. Returning to the moon marks the beginning of a new era in space exploration. More than just a scientific milestone, this new phase opens the doors to expanding humanity's presence in the universe, developing new technologies, and gaining a better understanding of the cosmos and our planet. The Artemis Project is not just a return to the past glories of the Apollo missions, but a bold step toward the future, where humanity will explore and live on other worlds. The moon will be the springboard for greater adventures, and space exploration, which began with the first steps on the lunar surface, will continue to open new horizons for humanity. The journey is just beginning, and the technological, scientific, and philosophical advances it will bring will shape the future of our civilization. Thus, exploring the moon will not only be a historic achievement, but a crucial part of humanity's future.